Hello and welcome everyone. My name is Mona Yadav and in this video we will be learning one more numerical related to viscosity based on parallel plates. So now we are aware that there are many conditions in which we can solve the numericals on viscosity, and in this video we will be solving the numerical related to condition of parallel plates. So the question is given as a plate 0.025 mm distant from a fixed plate moves at 60 cm per second and requires a force of 2 Newton per unit area, that is 2 Newton per meter square, to maintain this speed. Determine the fluid viscosity between the plates. So let us try to understand this question through the diagram. Now in this diagram we can see that there is a fixed plate. So this is the fixed plate about which the question is giving information. A plate 0.025 mm distant from a fixed plate. So this is the fixed plate, and a plate which is at 0.025 mm distance from this fixed plate is this plate, which is situated in the upward direction. So the distance between this fixed plate and this another plate is 0.025 mm. Moves at 60 centimeter per second. So this plate is able to move and it is moving at a speed of 60 centimeter per second. So that is represented in diagram as u equal to 60 centimeter per second. And requires a force of 2 Newton per unit area, that is 2 Newton per meter square, to maintain this speed. Now this plate is moving. So if this plate is moving, of course energy is needed to move this plate, to take this plate from one place to another place. So that energy is given by this force. So the force which is required for the movement of this plate is 2 Newton per unit area, that is 2 Newton per meter square. Now why this force is needed? To maintain this speed of 60 centimeter per second. Determine the fluid viscosity between the plates. So what we have to do? We have to determine the fluid viscosity between the plate. So there is a fluid between this fixed plate and this moving plate. And what we have to do in the question? We have to determine the viscosity of this fluid. So what is given? Given is the distance between the plates represented by dy. Dy, why we are calling it as dy? Dy is the change in distance. Change in distance from this fixed plate to this moving plate. So dy is equals to 0.025 mm, which when converted into meter, it is 0.025 into 10 raised to minus 3 meter. Velocity of upper plate u equal to 60 centimeter per second, which when converted into meter per second becomes 0.6 meter per second. Force on upper plate F equal to 2 Newton per meter square. This is given in the question. So what is given? A plate 0.025 mm distant from a fixed plate moves at 60 centimeter per second and requires a force of 2 Newton per unit area. But important thing to note here is that force is given in 2 Newton per meter square. And we know that the unit of force is only newtons, not Newton per meter square. So this value is basically given for shear stress. This value is for shear stress. Shear stress is tau equal to 2 Newton per meter square. We know that the formula for shear stress is shear force divided by area. So force will always be in newtons and the stress or pressure, its unit will be in Newton per meter square. So of course 2 Newton is the value of force for per unit area. So that's why the shear stress value is given tau is equal to 2 Newton per meter square. So it is very important to note that the values which are mentioned in the question, we need to carefully look for the units given along with them. So if the value for force is given as 2 Newton per meter square, it will not be the value of force, but it will be the value of stress. And the force will be responsible for generation of that stress. Now fluid viscosity between the plates is to be found out. Determine the fluid viscosity between the plates. So we have to calculate the fluid viscosity between the plates. That is, we have to find out the value of mu. So now we know these things are given in the question. So using the Newton's law of viscosity, we have the formula as tau equal to mu into du by dy where du is change of velocity. So du is representing the change of velocity. So u minus 0. Why u minus 0? This moving plate is able to move with the velocity of u, but this fixed plate is fixed. It is not able to move. So its velocity is 0. So that's why u minus 0 equal to 0.6 meter per second. Also dy equal to change of distance. So change of distance from which point? So the point where the plate is able to move and the point where this plate is fixed. So 0.025 into 10 raised to minus 3 meter, the distance which is given in the question. So dy is this value. So now putting all these values in the question, the value of tau, the value of du, dy, we get this equation. And by simplifying this equation, we get the value of mu equal to 8.33 into 10 raised to minus 5 Newton second per meter square. Now, if we want to convert this value of Newton second per meter square in poise, then we have to multiply it by 10. So after multiplying this particular value by 10, we get the value as 8.33 into 10 raised to minus 4 poise. So this is the final answer that we are getting for dynamic viscosity in this question. Thank you.